Welcome back, guys. We're just doing a video on multiplying fractions. I think it's very natural for us to add and subtract fractions. We're always putting things together or taking some away from it. This concept of multiplying fractions is a little bit more involved, and there's some steps that we need to follow. And there's also, what I like to point out for you, there's opportunities to cancel. And when we find those opportunities to cancel, it actually makes our life simpler because we cancel out some common factors. And it reduces this, when we do that, it reduces the size of the numbers that we multiply. And it makes it a little bit easier to do that as a mental strategy, okay? So I'll get behind the light board and show you those steps, and I'll talk you through a couple of little things that I see that might speed up your work or actually let you see what we're trying to do, okay? We're doing some work here on multiplying fractions, and hopefully we've started this in class by folding some paper. I'm just going to have a quick talk about that. And then multiplying fractions is about seeing the opportunities to cancel. And when you see them, it makes life easier. It makes the numbers that you're multiplying a lot smaller. So we'll get onto that in a second. So what I just wanted to just point out to you, I guess, is that if we fold a piece of paper in half and then we fold it in half again, what we've left with is a quarter. So that shaded area represents a quarter. So mathematically what we write is a half times a half equals, maybe we do this step, maybe we don't. But we have to know we need to multiply the numerators together, and we need to know that we multiply the denominators together. So maybe this step helps you see that, or we could just do all that work in our head and write a quarter. I guess the language is important here, because what we've got, what did we say here? We said a half of a half is a quarter, okay? Whether this is a piece of paper and we're folding, or we've got a knife and we're cutting something up into quarters, this is what we're saying. A half of a half is a quarter. So that word of is really important to us. Of, when you see it, you need to think multiply. That's your signal there. All right, so I'll leave that on the side there. And I want to try another one. I'm just going to set up a grid here, and I guess we can do the mathematics here. We're going to first use quarters, and then we're going to look at thirds. So if we just follow the process here, that's going to be 1 over 12. We know our answer. We've got our answer. And it's just now, all I want to do is kind of show to you how we get there. So I've changed the color of my pen here, and I'm looking now very roughly. I chopped it up into quarters. Okay, so we've got, if we look at this again, if we say the same sort of language, we want a quarter of a third. Now, it doesn't really matter for multiplication, doing multiplication, if I just change that around. What happens just if I said this, we want a third of a quarter, because I chopped this up into quarters first. Makes no difference. So here is a quarter, and we want 1/3 of it. So to do that, we need to think about what that represents. A third, if we chopped this into thirds, where it overlaps, here perhaps. I'm just shading that box in to say that is 1/12. Now, if you wanted to extend those lines out, you're most welcome to. You're most welcome to count up the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're all equal sizes. I guess my drawing's bad, but we've got to imagine that they're all equal sizes. And that overlap of a third of a quarter is here. It's sitting here, 1/12, one of the 12 squares. All right, so that's the style of thinking that I want to lead you down. And I'll just clean the board and we'll get into the game of cancelling. Okay, so we're back. We've thought about the concept of multiplying fractions, and now we're getting into this game of cancelling. And when you see the opportunities to cancel, you should. So let's start off just blindly multiplying these things together. We need to multiply the numerators together, and we need to multiply the denominators together. So perhaps writing it out this way is helpful for you. And then we crunch the numbers. Okay, 3 times 8 is 24. 4 times 9 is 36. Now they're both even numbers, so 2 could go in there, and you could take this long road of 2 goes in there 12 times, and 2 goes in there. Halve that number and we're at 18. Both even numbers, so we can apply this again. 6/9. Now I see 3 as a common factor, and we can write this as 2/3. Or we could have saw that 12 was a common factor and wrote this as 2/3. So there's our answer. And I'm going to do this question again, showing you different ways to think and approach. So that is the long way around the block, I guess you'd say. This time, I want to think about it a little bit differently. I'm going to write it out again. And I'm going to show you one technique here. And the basis of this is, let's just use these numbers up here. It really doesn't matter if I do 4 times 9 or 9 times 4. We both end up both ways we end up at 36. So I'm looking at these fractions, and perhaps it might be easier if I write what I've got here as 3/9 times 8/4. Okay, the answer there is still 24/36, and we can cancel down to get our final answer of 2/3. All right, but that's not the reason why I did that, because you can swap the denominators and the numerators around. As long as you've got a multiply sign here, that's all okay. And why did I do that? Because I set them up as fractions that maybe you can see they cancel down, because you can see, looking at each fraction separately, you can actually see that they can be simplified. And I'll just wipe the board here clean and write out the new things that I see. That 1 times 2/3 times 1. Now again, you don't need to write this step. If it helps, do it. All right? So that's a second way of answering the same questions, by employing this little trick here, where you can rearrange the numerators and or the denominators of the fraction, because we're multiplying. Okay, you can do that. Just be very careful. You can't do that when you're adding or subtracting or anything like that. But certainly when you're multiplying, you can do this. And I'm going to rewrite this out again and show you another technique. This one can cause a few issues because as it's set up here, we can do some cancelling on the diagonals. Okay, so this is a diagonal running through here and another diagonal across here. I can cancel on the diagonals. Just be really careful that you don't go crossing out numbers sideways like this. Okay, either on the numerator or the denominator. So I've made a mess of all that. I'm going to rewrite it over here and show you what I would do as the fast way around the block here. And I'm looking on the diagonals. I see 3 goes into 3 once and 3 goes into 9 3 times. And this is exactly what I say to myself in my head when I'm doing this work. Okay, 4 goes into 4 once. So I cross that number off neatly and I write the new number beside it. Okay, a little bit smaller so I can keep track of things. So 4 goes into 8 twice. So what am I left with? I'm looking here, I've got 1 times 2, so that's equal to 2. And on the denominator, I've got 1 times 3, which is 3. And if I do a neat job of that, I don't like seeing students come in here and cross all this out like they're trying to erase the number. You need to see the number that's underneath. Okay, because then you can check your answer and check that you haven't made a mistake anywhere while you're doing this work. Now the final part of this video, I just want to show you a few other tricks, if you like, for multiplying fractions and mixed numbers and things like that. So one of those tricks here is if we have 5/6 of 16, and we need to set this up as 5 over 6. Of means multiply, so that's times sign, put the times sign in between them, and 16 over 1. There's still 16 as a whole number, but it looks like a fraction, and that's helpful because I can see ways to cancel now along the diagonal here. I'm seeing something here. I'm seeing that they've got a common factor of 2, so 2 goes into 6 3 times, and there's a common factor here of 2, and we can rewrite that as 8. And then crunch our numbers, and we've got 40 over 3, and we might want to rewrite that. I'm thinking, what have we got? We've got 40. I'm thinking about 40 is equal to 39 plus 1. And so 3 will go into 39 13 times, remainder 1. And so I'm going to write it like that. Okay. I just got another question here. Similar sort of thing. What do we do when we have a 8 over 5 times 15 over 4? Okay, so I'm cancelling on the diagonals here. 4 goes into 4 once, so 4 goes into 8 twice, 5 goes in here once, and 5 goes in here 3 times. So what do we end up with? I set up the fraction line because I'm never sure after doing all that cancelling what's going to happen here, and I'm looking up on the numerator. 2 times 3 is 6, and on the denominator, the common mistake is a lot of students think that because they've cancelled down it turns into nothing. But 1 times 1 is 1. And you're okay to leave your answer like this, or you can just turn it back into represent it as a whole number rather than a fraction. Okay? Similar sort of thing to what we're just talking about. So when we're working with mixed numbers, it's really important that you turn them into improper fractions. And do this step first. Alright, so I've got an example here. Maybe we'll do this one. 2 1/3 times 1 and 2/5. Okay, turn them into the improper fractions, because I see a lot of students look at the whole numbers and go, oh, that's got to be 2 and something, and get it wrong. So 2 times 3 is 6, add 1 is 7/3. Multiplied by, I'm looking here, 1 times 5 is 5 plus 2 is 7/5. I'm looking for ways to cancel. I don't see any, so I'm going to have to write this out as 7 times 7, square number, so that's 49/15. And that 49 I'm thinking about as 45 plus 4. So my final answer down here will be 15 goes into 45 3 times, and I've got 4 left over, 4/15, and there's my final answer. I've converted it back into a mixed number at the end. So just be careful what the instructions ask you to do. And sometimes it's okay to leave it here as an improper fraction, but sometimes just be careful in the textbook. The instructions are quite specific. On a test, they're quite specific about what they want you to leave your answer in its final format. So thanks for listening, and I hope that's helped.